Right, question 10. It's a bit of a, well, it is an extension question, this one really. It's telling you that you have calibrated a calorimeter using 2 grams of methanol, and you're told that the delta H was negative 715 kilojoules per mole, and that the change in temperature for that reaction was it increased by 32.8 Kelvin. And you're also told, well, you're told the 2 grams, so you can work out the number of moles of this substance used, and that would be 2 divided by 32, and that equals 0.0625 moles of methanol used to calibrate the equipment. Now, first thing you need to do then is you're kind of working backwards on this one. So you are given the delta H value, you don't know the Q value, and you know the N value. So you need to rearrange this to work out what the Q value is. So it's going to be, so delta H times by N is going to be equal to the negative Q. So if we put the values in, negative 715 times by N, which is 0.0625, we find out that Q, or negative Q, is equal to negative 44.6875 kilojoules. Now, obviously, if we then get rid of the negatives, Q is going to be equal to this value here. Right, next then, we need to work out the specific heat capacity of the calorimeter itself, and what that means is that it's this here. So the MC is going to be our total calorimeter, both the mass of the calorimeter and the water inside, and the specific heat capacities associated with both of those materials. So we need to rearrange this to find out what MC is, and that's going to be equal to our Q value here divided by the temperature change, and that is well, it says it up here 32.8, so that's going to be 44.6875 divided by 32.8. What that tells us is the specific heat capacity for the entire calorimeter, and that's going to be constant because it's used both times in this experiment, and that comes out as 1.363 kilojoules per gram per Kelvin. Right, the next step. Alright, now we know this value here, so I'll write that down. So MC is equal to 1.363. The next step is, the part of the question is, the same calorimeter is used to measure the enthalpy of combustion for propan-2-ol. 1.5 grams of propan-2-ol raise the temperature from 19.8 to 56.2, calculate the heat capacity of the calorimeter, and then the energy of combustion of propan-2-ol. So now, MC delta T, we know this value is this one. The change in temperature for this second reaction was 36.4 Kelvin, so then we can work out what Q is. So that's 1.363 times by 36.4, and we get 49.61 kilojoules. The final step then is delta H is equal to the minus Q value divided by the number of moles used, and we used 1.5 grams divided by 60, and that is equal to 0.025 moles of propan-2-ol. So sub your values in, minus 49.61 divided by 0.025, and the final answer is negative 1984 kilojoules per mole.